Okay, we're going to talk about Newman projections. Newman projections are really a way of drawing molecules in order to describe their shape or conformation. And Newman projections are really useful when we're talking about the shapes or conformations of alkanes, because they're good at describing how a particular carbon-carbon bond is rotated at a particular time. And so let's start with something easy. Let's start with ethane and try to describe and draw out the different types of conformations of ethane using a Newman projection. Okay. Well, before I get to the Newman projection, let me just sort of write this out a little more detailed with some wedges and dashes to show more of the tetrahedral nature of each of these carbons in our ethane. And really, based on this, we'll be able to draw maybe a Newman projection that's able to show the relative positions of each of the hydrogens around the carbons a little bit better. Now, when drawing a Newman projection, we always sort of draw this shape and then make a circle sort of on the inside of it. Now, a Newman projection is meant to illustrate how a molecule looks while observing down a carbon-carbon bond. So there's only one carbon-carbon bond in ethane, and so we're going to be imagining that our eyeball, we draw a little eyeball, is right here looking straight down that carbon-carbon bond. Now, this is the carbon closest to our eyeball, and it's represented by the junction between these three lines. That little space intersection right there is the first carbon. We've made it very small so that we can see what's behind it. The second carbon in the back is this huge one there, and we've accentuated its size so that we can see it. It's not eclipsed or masked by this first carbon. Now, if we are looking at this near carbon here, there are four things attached to this carbon. One of them is the carbon behind it, which we've already represented by this big circle. And then it has three hydrogens. And so those we can put at the ends of the three bonds here. Okay. Now behind this carbon, the carbon in the back, is also bound to the first carbon, and it's bound to three other hydrogens also. And so what I've drawn here is a Newman projection of ethane, and it's a Newman projection that shows that these hydrogens on all of the carbons are as far away from each other as possible. And this is called the staggered conformation of ethane. Staggered, I think, only has one R. But I can use a Newman projection to draw lots of different possible combinations. Right? Imagine rotating this carbon-carbon bond and altering the orientation of hydrogens relative to each other. So let's draw another Newman projection here that describes a different type of conformation. I always start by drawing this for my Newman projection. Again, the first carbon that I'm looking at has three hydrogens along with the other carbon. And now I'm going to imagine twisting that second carbon, rotating it so that its carbon-hydrogen bonds are more in line with the carbon-hydrogen bonds on the near carbon. Okay. These, you would imagine, this is a higher energy, less stable conformation, but it's also a possible one. And really any rotation in between these two is a possible one. This conformation where the hydrogens are sort of blocking the other hydrogens, they're eclipsing them, they're in the way, we call this an eclipsed conformation. Okay. Now we can draw other Newman projections, not just of ethane, but we can imagine any sort of carbon chain. You can draw a Newman projection that can describe any carbon-carbon bond. I'm going to do a couple different Newman projections for this one to illustrate what I'm talking about. But let's sort of number this one just to make things clear. I'm going to, let's call that the 5th. I'm going to draw a Newman projection that's looking down the C2, C3 bond. So I would imagine my eyeball would be here. This would be my near carbon. That would be my far carbon. Let's draw a staggered Newman projection that describes a possible conformation of this molecule, 2-methylbutane. Okay, so if I'm going to draw a staggered conformation, I'm going to have these bonds as far away from each other as possible, 120 degrees between each of the bonds on one carbon and 60 degrees between the bonds on different carbons. Now, I know that this is a carbon, and this is my C2 carbon. I know the big carbon in the back is my C3 carbon. I just have to figure out what are the 3 other things attached to these carbons. So if I think of this as my C2, it's bound to the C3 behind it, and it's also bound to what else? A methyl group, and there's another hydrogen here that's not indicated in the skeletal structure. I can put these wherever I want. I just have to have the right substituents on that carbon. Okay, now here's the C3 carbon in the back. What are the things attached to it? Well, it's attached to the C2 carbon, but that's already accounted for in my Newman projection. What are the 3 other things? A methyl group and 2 other hydrogens that are not shown in the skeletal structure. So let's just draw one possible staggered conformation of this molecule. You might imagine this would not be the lowest energy molecule. It might be better if I had rotate that carbon-carbon C2-C3 bond so that this methyl group ends up over here or over here. That would be lower energy, and we'll talk about that in a future video. But this is a Newman projection that represents one possible conformation of 2-methylbutane. Okay. Now, I don't have to always choose this middle carbon-carbon bond to do a Newman projection. Often that's the most useful one to look at, but you could choose any carbon-carbon bond here and describe what's a Newman projection description of it. So let's look down the, let me see, C1, C2 bond and do a Newman projection for that. Here I would imagine my eyeball would be here. Make my Newman projection. The C1 carbon, the one nearest me, has a bond to C2 and 3 other hydrogens. It's just a methyl group. The C2 has a bond to the C1, and then it's bound to 3 other things, a methyl, an ethyl, and a hydrogen. So I'll put a hydrogen here, I'll put a methyl here, CH2, CH3 to describe the ethyl group. Both of these are Newman projections of the same molecule, but they're describing the shape or the conformation on looking at different carbon-carbon bonds.